Assalamualaikum and hi, my name is Nur Balkis Humaira. I am one of the students from Applied Science Faculty, or we usually call it as FSG. So for today, I'm going to present about the topic that I choose for my chemistry assignment, which is the chemistry of soap. So without further ado, let's get right into the video. Okay, so for the chemistry of soap, here's other content that I'm going to talk about and present about. So here in the introduction part where I'm going to tell you the definition of soap. So basically soap is a salt of a fatty acid used in a variety of cleansing and lubricating products. As you guys might know that soap has been widely used all over the world. So there must be a lot of common uses of soap that you might know and didn't know, isn't it? So let me tell you, in a domestic setting, soap has been used for washing, bathing, and other types of housekeeping. Meanwhile, in industrial settings, soap has been used as thickeners, components of some lubricants, and precursors to catalysts. Here is the synthesis of a soap. Soap is produced by the saponification hydrolysis of a triglyceride, or we usually call it as a fat or oil. So as you can see at the figure 1, in this process, saponification of triglyceride, the triglyceride which is located at the left side is reacted with a strong base such as sodium hydroxide to produce glycerol and fatty acid salts. The salt of the fatty acid that I'm talking about is sodium palmitate, which is called as a soap. Okay, so in the previous slide, I did mention about fatty acids, right? And I know some of you might be wondering, what is fatty acids? What is it? Okay, so I'm going to tell you that fatty acids actually are straight chain monocarboxylic acids. The carbon-carbon bonds in saturated fatty acids, they are all single bonds. Meanwhile, the unsaturated fatty acids, they tend to have one or more carbon-carbon double bonds in their chains. For an example of a saturated fatty acid is palmitic acid. Yes. Did you know that certain soap, they will have palm oil as one of the ingredients? Yes. And I just want to let you know that palm oil is made up of palmitic acid. The palmitic acid fraction of the oil will provide some hardness to the soaps when it's bonified. And once it's bonified, the palm oil will produce sodium palmate when it reacted with sodium hydroxide. Moreover, fatty acids, they are seldom found as free molecules in nature, but they mostly are a part of a larger molecule called a triglyceride. So, as you guys can see in the figure 1, which is the same figure like the other previous slide before this as well, let's focus at the triglyceride part, shall we? Okay, so as you guys can see, there are 3 carbon atoms bonded to each other. And the one that makes the 3 carbon atoms bonded to each other, we call it as a glycerol backbone or 3-membered carbon chain. As we referred to the same figure, for the fatty acid, they are bonded to each of the 3 carbon atoms in the glycerol backbone. And the bond between the fatty acid and the glycerol backbone is referred to be known as an ester linkage. So, in this process, in this saponification process, in order to form glycerol and soap, the ester linkage must be broken. Next, in properties of a soap, basically soaps are potassium or sodium salts of a carboxylic acid having a long aliphatic chain attached into it. And they are surfactants, which is the compounds that reduce the surface tension between a liquid and another substance, and therefore help in the emulsification of oils in water. The mechanism of cleansing action of soap. So, soap have certain chemical structures, and the molecules contain a hydrophobic part, which is the water insoluble. For an example, fatty acid, fatty alcohols, or alkyl benzene. Besides, the molecule also contains a hydrophilic group, which is the water-soluble one. For an example, RCOONA or a sulfur group, which is ROSO3Na or RSO3Na, such as in fatty alcohol sulfate or alkyl benzene sulfonate. So, its hydrophobic will end when they attach themselves to the dirt and remove it from the cloth. The molecules of soap will arrange themselves in micelle formation, then the dirt will be trapped at the center of the cluster. These micelles will remain suspended in the water. So there's a lot of types, forms of soap around us. It's just that maybe you are aware or not about it. So let me tell you that some forms of soap are liquid soap, bar soap, which is made in some kind of block shape. And then we also have the dish soap and laundry soap to help pull away the dirt and grime from the clothing and rinse it out with water. And lastly, we also have hand soap. And yeah, not to forget, we also have antibacterial soap. So guess what? We're already at the end. And yeah, those are such a little bit of information about chemistry of soap that I would like to share with you guys. And I think that's all from me. Bye!